This video is continuation of mathematical modeling, and today I explain some more established mathematical models. First is compound interest model through algebra, and same model through calculus, and one more is prey-predator model. I explain these three things today. First is compound interest model. Through algebra. Compound interest model means we derive a formula which can be used to calculate the compound interest, and here the steps involved are the steps of mathematical modeling, and therefore it is a derivation is by mathematical modeling. Say first step is, suppose P is the principal amount. Let P be the principal amount. What do you mean by principal amount? That is the working capital you can take. K% be the rate of interest. Therefore, we take rate of interest as R. R is equal to K by 100. Rate of interest means, here rate of interest may be calculated monthly or quarterly or half yearly, yearly, so on. In compound interest can be calculated monthly also, or quarterly, or half yearly, or yearly. But we take yearly here. For 1 year, interest earned is P into R by 100, because P is the capital and interest is R by 100. Therefore, interest earned is P into R by 100. This is P into R it is. Rate of interest is taken as R. R is K by 100. Interest earned is P into R. Therefore, amount after 1 year is total amount. See, we have invested P rupees, and rate of interest is K%, therefore K by 100. We have taken that as R. Therefore, interest earned is P into R, and amount after 1 year is P plus P into R, or P into 1 plus R. See, the example is, suppose we invest 10,000 and rate of interest is 10%. Rate of interest is 10%. For 10,000, what is the rate of interest? 10%. Therefore, 10,000 into 10 by 100. So, what is this interest earned? 1,000. And what is the amount after 1 year? 10,000 plus 1,000. 11,000. It will be 11,000. Interest earned after second year, or at the end of the second year, is P into 1 plus R into R it is. Because, say, for the second year, if the interest is calculated compoundly, interest is compound interest, then the principal amount will be P into 1 plus R. At the end of the first year, amount is P into 1 plus R, and this becomes the capital for the second year, because interest is occurred compoundly. So, after second year, at the end of the second year, interest earned is P into 1 plus R into R. Therefore, what is the amount after second year? At the end of the second year is P into 1 plus R plus P into 1 plus R into R, because this is the interest. For the second year, this is the interest, P into 1 plus R into R. What is the capital? P into 1 plus R. So at the end of the second year, what is the total amount? Total balance is P into 1 plus R common, 1 plus R common, into 1 plus R. Therefore it is P into 1 plus R whole square. So at the end of the second year, if you invest amount P in the beginning, at the end of the second year, what is the total amount? P into 1 plus R whole square. Similarly, at the end of the third year, interest earned is P into 1 plus R whole square into R. Because at the end of the second year, capital is P into 1 plus R whole square and rate of interest is R. So this is only interest earned, and the amount, total balance is, your amount invested is P in the beginning. At the end of the third year, it becomes P into 1 plus R whole square plus P into 1 plus R whole square into R, because this is the interest. Interest will be added. What is the capital at the end of the second year? P into 1 plus R whole square. What is the interest earned? This is the interest earned. Total amount is this. So it is P into 1 plus R whole square into 1 plus R. Take this common. P into 1 plus R whole square common. Therefore, at the end of the third year, amount will be P into 1 plus R whole square, 1 plus R whole square into 1 plus R is 1 plus R whole cube. So, after n years, you will get amount will be P into 1 plus R raised to n. This will be the amount. And it is a compound interest model. And important thing is R is rate of interest, P is amount invested in the beginning, and the rate of interest is calculated annually. And this is called compound interest model, and it is derived by algebra. Now I explain same model can be derived using calculus. Compound interest model through algebra. Using algebra, compound interest model. Now here we take XTB, the amount invested for the time period T. X of T be the amount invested, and K% be the rate of interest. K% be rate of interest. Therefore, R is K by 100. Rate of interest is taken as R. It is K by 100. Let us invest the amount. Let us invest the amount for amount is X of T for the time period delta T. Here the advantage is delta T may be any time interval. Delta T may be 1 month, 2 months, 3 months, 9 months, any time here, delta t. Say we have invested x of t, it is for the time t, and we have to find out what is the amount at the end of time t. For that we use calculus here. What we have taken here? Next thing we have taken, suppose xt is invested for only short period delta t. Therefore, xt plus delta t is, what is this? Amount at the end of t plus delta t is, amount at the end of the time t plus delta t is xt plus, what is the interest? R into xt, R into x of t into delta t, because time is there, time interval is not 1 year, it is any time interval, plus O delta t, and O delta t is infinitesimal and tends to 0 as delta t tends to 0. Delta t tends to 0. Now, therefore, what do you have to find out? We have to find out x of t finally. It is invested for time t. For that, first we take, suppose xt is invested for a short period delta t. Then xt plus delta t means amount at the end of that time period. T plus delta t is xt, that is the capital, and what is this? Interest. Rate of interest is R into xt gives interest. Time is, for this time is delta t. And O delta t is a infinitesimal and it tends to 0 as delta t tends to 0. Therefore, x of t plus delta t minus x of t is R x of t delta t plus O delta t. Now divided by delta t. X t plus delta t minus x of t divided by delta t is R x of t, means R into x of t plus O delta t upon delta t. O of delta t upon delta t. Now as delta t tends to 0, this O delta t upon delta t tends to 0. Now we take limiting case. Limit delta t tends to 0, x t plus delta t minus x t upon delta t is limit as x tends to delta t tends to 0. Right hand side is R into x of t only, plus 0 it is. Plus 0, because as delta t tends to 0, O delta t upon delta t also tends to 0. Now what is this? D by dt of x of t is equal to R into x of t. R into x of t. Therefore, it is a first order differential equation now. Now, what do you have to find out? We have to find out x of t now. Because x of t is the amount invested for time interval t. And R is the rate of interest. It is compound interest. And we have to find out x of t. To find x of t, we separate the variables and integrate, we will get x of t. Therefore, dx of t divided by x of t is equal to R dt. Variables have been separated. Now integrate. Integrating we get, what is dx of t upon x of t? It is f dash x upon fx. What is integration f dash x upon fx? Log x of t is equal to R into t plus c. What is c? C is constant of integration. C is constant of integration. Therefore, x of t is e raised to RT plus c, e raised to RT into e raised to c. Take this as a e raised to RT. This is x of t. A is constant here, and how to find the constant? Initially when t is 0, x0 is a e raised to 0, a. Therefore, a is equal to x0. Therefore, x of t is a, means x0 e raised to RT. This is the compound interest model through calculus. This can be used as a formula to find the compound interest. What is x0? x0 is amount at the beginning. It is at the beginning. xt is amount at the end of time t. R is rate of interest. It is called compound interest model, and we have derived this one through calculus. Next, consider one more, prey-predator model. Prey-predator model. Now I explain one more established mathematical modeling. It is called prey-predator model. All of you know what are prey and predator. Prey-predator. Prey-predator is used only usually for animals, but that can be used for that plants also. Prey-predator is used for only animals, that can be extended to plants also. What do you mean by prey-predator? Predator means animal which hunts other animals for its food. And that animal which is killed by this predator is called prey species. Follow now what is predator? Predator means an animal which hunts other animals for its food. And prey means it is a creature which is killed by the predator for its food. So prey is a food for predator. Standard example for this is, I explain some example for this, predator and prey, then you can easily follow. Predator and prey, example, predator, prey. Predator is lion. Prey is zebra here. Lion kills zebra for its food. And that is, lion is predator, zebra is prey. And bear and fish. Fish is the prey here. Bear is the predator. Fox and rabbit. Fox is the predator and rabbit is the prey. Now we derive prey-predator model. That means what does prey-predator model gives? Prey-predator model gives at any time t what is the number of predators and what is the number of prey. Prey-predator model gives the number of prey species and predator species. Now for that we assume the following. For that, suppose let us start with xt be the number of prey species. Xt be the number of prey species and yt be the number of predator species. Xt, yt. Prey xt, predator y. At any time t. Now we assume the following. So mathematical modeling means we have to derive a model which gives number of prey and predator species at any given time t. For that we have to assume certain things here. What is the first one? First one is, if there are no predators, then what happens? Predators. If there are no predators, prey species grows at the rate of population of prey species increases at the rate of prey species itself. Here we use Bernoulli's notion. What is Bernoulli's notion? Bernoulli's notion is capital increases at the rate of capital itself, or rate of interest of capital is proportional to the capital. Now suppose there are no predators, then prey species are free and the population of prey species increases at the rate of prey species itself. If there are no predators, the population of prey species increases at the rate of prey species itself. Second one, here important thing is prey species increases here. Suppose there are no predators. Second, suppose if there are no prey species. There are no prey species. Then what happens? Predators will not have any food. If there are no prey species, predators will not have any food and they will not survive. Their population decreases. And what rate a population decreases? Population of predators decreases at the rate proportional to predators only. And third thing, here decreases means minus, increases means plus. That you have to remember while forming a model, constructing a model. Next is, if both are present. Suppose there are prey species as well as predators. Then the population of predators increases at the rate proportional to the product of both prey and predators. And population of predators increases. At the same time, population of prey species decreases at the rate proportional to product of both prey and predator species. Now these are the three assumptions. What are they? First one, suppose there are no predators, prey species increases at the rate proportional to itself. Suppose there are no prey species, the predator species decreases population at the rate proportional to rate of predators only. Suppose both are present, this case important, population of predators increases, population of prey decreases. At what rate? At the rate proportional to product of the prey and predator species. With this assumption, we will have a model now. Now, these assumptions give a system of linear first order ordinary differential equations. How do you get that one? See, we have dx by dt is, what is this? Rate of change of prey species. It is equal to a into x. Because, see, first assumption, when there are no predators, rate of change of prey species is proportional to their population. Therefore, dx by dt is ax. And if both are present, dx by dt is minus bxy. When both are present, we have this. Only preys are there, we have dx by dt is this. Both are there, dx by dt is this. And dy by dt, what is this? Suppose there are second assumption, there are no preys, the predator, y is predator population, it decreases at the rate proportional to the population of predators minus py, and dy by dt is also it is half. Suppose both are present, here what happens? When both are present, prey species decreases, but when both are present, predator species increases. So I take qxy. This implies dx by dt is ax minus bxy, dy by dt is minus py plus qxy. So this gives dx by dt is a minus by into x, dy by dt is minus p plus qx into y. Now we have to find out x and y, population of prey and predator species. What is this here? A, B, P, Q are greater than 0. A, B greater than 0. P, Q are greater than 0. Now, from this, take this as 1, this as 2. From 1 and 2, what do you get? dy by dx is dy by dt upon dx by dt minus p plus qx into y divided by a minus by into x. 1 by 2 gives this. Now, this is first order linear ordinary differential equation, and we can solve this one. How do you solve this? By separating variables. So how do you solve? Dy upon separating variables. Say I write that like this: a minus by upon y into dy is minus p plus qx upon x dx. Separating the variables. First we have used Bernoulli's notion here, and then dy by dx is dy by dt upon dx by dt. Dy by dx is dy by dt upon dx by dt. Using this we have obtained first order linear differential equations, and we have separated this also, integrating between the limit y0 to y, a minus dy by y dy is equal to x0 to x minus p plus qx upon x dx. Now what is this integration? A log y from y0 to y minus b y from y0 to y is equal to minus p log x from x0 to x plus q x from x0 to x. Integrating between these limits y0 to y, x0 to x. Therefore, a log y by y0, log y minus log y0, I have written as log y by minus y0, minus b into y minus y0 is equal to minus p log x by x0, because log x upon minus log x0 is x upon x0 plus q into x minus x0. Q into x minus x0. Now, simplifying we get. How do you simplify? Say I like simplify like this. A log y minus y0 plus p log x by x0 is equal to q into x minus x0 plus b into y minus y0. This is a prey predator model. We know what are p, q here. Suppose p by q and a by b. P by q and a by b. P by q, let me explain. If the initial population of prey and predator species are prey and predator species are P by Q and A by B, then population becomes constant. There is no change in the population of prey and predator species. When initial population is P by Q, predator is A by B, then there is no change in the population. And this serves as prey predator model. Prey predator model. Some more standard established mathematical models let me consider in the next video. Okay, thank you.